You know, when you think about sending a secret message, what's the first thing that comes to mind? Probably scrambling it up, right? Making it unreadable. But what if the best secret isn't one that's scrambled, but one that nobody even knows is there? That's what we're digging into today. The two very different sides of secret messages. Hiding them versus, well, proving they're the real deal.
So, let's just jump right in with that big question. How do you send a truly secret message? Yeah, your mind probably jumps straight to encryption, making it all look like a jumble of nonsense. But we're going to start from a totally different angle. What if the best way to keep a secret is to make it look like there's no secret at all?
And that right there, that's the first huge distinction we need to make. On one side, you've got encryption. Its whole job is to make a message unreadable, to scramble the content. But on the other side, you have something called steganography. And its goal? It's totally different. It's not about scrambling the message. It's about hiding the fact that a message even exists, making it completely, utterly undetectable.
Okay, so let's dig into that second idea first. The art of making messages just disappear, to make them totally invisible. And it's a practice with a pretty awesome name, by the way.
It's called steganography, and that name actually comes from the Greek for covered writing, which is perfect. The whole idea is to tuck secret data inside something that looks totally normal, totally boring. You know, like a family photo, an MP3 file, or, hey, even a simple shopping list. Think of it as the ultimate digital camouflage.
And get this isn't some newfangled digital trick. Nope. People have been doing this for centuries. We're talking ancient Greece, where they tattoo messages on a messenger's shaved head, wait for the hair to grow back, and then send them off. The term itself was actually coined way back in 1499. The only thing that's really changed is our medium. We've just swapped out scalps for pixels.
All right, so how does this actually work in practice? Let's look at a couple of examples. We'll start with a really simple one, something you could do yourself, before we get into the more high-tech stuff.
Okay, check this out. Just a totally normal-looking shopping list. Take a second. Do you see anything secret here? I mean, it looks completely harmless, right? And that is exactly the point of good steganography. Anything jumping out at you yet?
Aha! There it is. That's the moment, right? If you just take the first letter of each of those first few items, A, S, E, C, R, E, T, you get a secret message. It's brilliant, right? It shows the core principle perfectly, hiding something right out in the open where no one would ever think to look.
Okay, cool. Now let's take that exact same idea and bring it into the digital world. A really common technique is called LSB embedding. So every digital picture is made up of millions of tiny dots, right? Pixels. And each pixel's color is defined by a string of numbers, of bits. LSB embedding is super clever because it works by changing just the very, very last bit in that string, a change so small our eyes literally can't see it.
So here's the play-by-play. You take one bit from your secret message, just a single 1 or a 0. Then you find one pixel in your cover image. You swap out the very last bit of that pixel's color code to match your secret bit. And then you just do that again, and again, and again, thousands of times, until your entire message is tucked away, pixel by pixel, inside a photo that looks exactly the same as it did before. It's totally invisible to the naked eye.
All right, so that's how you make a message invisible. Pretty cool. But this whole idea is built on one assumption, that your biggest worry is someone finding your message. But what if that's not your problem? What if you actually don't care who sees it, you just need them to know it's really from you and that nobody's messed with it? What if the problem isn't secrecy, but trust?
And this is where we pivot. We're moving away from the art of hiding and into the science of trust. And for that, we need to talk about something called a MAC.
A MAC, that stands for Message Authentication Code, is basically a short piece of information that gets attached to your message. The absolute best way to think about it is like a digital tamper-proof seal on an envelope. You know, if that wax seal is broken, you know for a fact someone's been messing with what's inside. So what does this digital seal actually promise you? Well, two really important things. First up, message integrity. That's the proof that your message hasn't been changed. Second, message authentication. That's the proof it came from who you think it came from. But, and this is a big but, there's a key limitation here. Because both the sender and the receiver use the exact same secret key, the sender could, in theory, deny ever sending the message. It's this idea called repudiation. And MACs, well, they just don't protect against that.
So let's do a quick walkthrough of how this digital seal actually gets created and then checked. It's a really elegant process when you see it in action.
Okay, here's how it goes down. The sender takes their message and a secret key that only they and the receiver have, and they use it to generate this unique digital tag. That's the MAC. Then they send the original message and the MAC tag over to the receiver. The receiver then does the exact same math on their end, using the message they got and their copy of the secret key. If the tag they create matches the tag the sender sent them, bam, the message is authentic and unaltered. If they don't match, someone tampered with it along the way.
And believe me, this isn't just some abstract theory. You are using Macs all day, every day. The two most popular flavors are HMAC, which is built on something called hash functions and helps keep the websites you visit secure, and then there's GMAC. That one's based on block ciphers, and it's super important for securing high-speed connections, like when you're using a VPN.
And why are they so popular, especially something like GMAC? One word: speed. Because they're built on what's called symmetric key cryptography, they're just incredibly fast. We're talking speeds of 10 gigabits per second, and that is absolutely essential for locking down the high-speed connections that basically power our entire modern internet.
Okay, deep breath. Let's bring this all home. We've looked at the art of hiding, we've looked at the science of verifying, now let's put them head-to-head for the final showdown.
So, let's just boil this all down to its core. Steganography, its goal is to be undetectable. A MAC, its goal is to prove a message is unaltered. Steganography is asking the question, is there even a message here at all, while a MAC asks, is this message the real deal? It really is camouflage versus a tamper-proof seal.
And this quote really just hits the nail on the head, doesn't it? Steganography is all about protecting data by making it invisible, undetectable. Meanwhile, a MAC provides integrity by making sure that any manipulation, no matter how small, is detected instantly. They're just two completely different philosophies when it comes to protecting information.
All right, so if you're going to remember just a few things from all this, what should they be? Here are the key takeaways. Steganography hides the existence of a message. MACs verify the authenticity and integrity of a message. At the end of the day, one is about being invisible and the other is about being trustworthy.
And that really leaves us with one last big question to chew on. As we head deeper into a future that's going to be filled with AI-generated content and incredibly convincing deepfakes, which of these two ideas is going to matter more? The ability to hide our data completely, or the ability to prove without a doubt that it's real?